We're back. So, few things. Welcome to Wednesday. It's all very exciting. The live stream link on the website is wrong, but will be fixed shortly. It was right, and then computers. So it became wrong. These things happen. But anyway, I just wanted to kind of welcome everyone back and say that we are going to have quick intro, quick set of guidelines, rules, etc. And then Debbie is with us. By the way, I feel like I did a bad job at introducing the actual organizers. So hi, I'm Bridget.
Hello, I'm Debbie Gillespie.
All right, fantastic. And Debbie, how is it that people are getting snacks and a hotel and live stream? What's paying for all that?
That would be our sponsors. We have, yes.
Woo!
Your ticket price would be way more expensive if we didn't have sponsors. Yeah. So please, go say hi to our sponsors.
Yeah.
They deserve our love.
Yeah. And what specific timing of something is happening that they should definitely talk to the sponsors before?
So today is the raffle, which will be happening at 2:30 p.m. And I've seen some really, really nice prizes being raffled off by our vendors, or by our sponsors. There's Nintendo Switches, I've seen a Raspberry Pi kit, a TV. So
Legos, there were Legos.
Legos, there are Legos as well. So all you need to do is stop by the sponsor booths, hand them your name, enter your name in the raffle, and show up at 2:30 to hopefully claim your prize.
And I know that a bunch of the sponsors are also perfectly happy to drop ship some of their raffle prizes. So even if you're watching on the live stream, you should still fill out whatever. Go look in the Slack, click on all the sponsor channels, and enter all of their drawings.
Indeed.
All right.
And one of the benefits this year of it's not as large of you have a better chance of winning this year. Usually there's 800 to 900 people out there. So this is your year to win a prize.
All right, fantastic. Well, let's tell them about a couple of the other things before we hear from one of our sponsors and then our first speaker. You got 2 talks this morning. We'll hear more about those in a minute. Then we've got a break. What should people do on the break?
They should go visit the sponsor hall.
Exactly. Get those prizes, get those stickers. I work for a sponsor myself, and I can assure you no one wants to take a bunch of little stuffed creatures home or, whatever. Like, no.
And if you're online, you should go visit the Zoom breakout rooms. There are sponsors there. You can also enter your name for raffles there. And there's the Slack channel. So many opportunities to interact with our sponsors this year.
Yeah, and just like yesterday, we still have a code of conduct. Unlike yesterday, you're going to have a lot more interactive components if you participate in the open space discussions, or if you in the open space in Zoom breakouts or in person. More on that after the lunch break, during which we will not serve you lunch because COVID. So, noon to 1:30, go forth, wander, be safe, and then you'll be back here at 1:30 to do the open space, assembly. Avengers Assemble, open space assemble. But then after the open space assembly, then they will have the opportunity after one set of discussions to win prizes and then have more discussions.
Yep. Come back here for the raffle at 2:30.
Yeah. And there's actually breakfasty type stuff that you probably have grabbed now, but you'll be able to grab that on the break as well when you visit the sponsors. Yeah. That's pretty much that. Oh, people were asking about t-shirts, and while t-shirts are a limited supply item for all of the obvious reasons, we do have a link that will be coming that, if not by end of day today, will be in the post recap email where t-shirts can be ordered. So, all right, that's what I've got. Debbie, you want to tell us about the sponsor that we're going to hear about next? And
yeah.
I'll step off stage and let that happen.
All right, thank you much. So the first sponsor we're going to hear from today is Chef Progress. And they sent us a video that we can check out.
Hi, Minneapolis DevOps Days. We're so glad to join you for this incredible event. So why Chef? First and foremost, Chef is awesome. Lots of folks think of Chef as Chef of 5 years ago, focused on infrastructure as code and not so much on containers and Kubernetes. But Chef has come a long way in the last few years. Our new solution stack supports container and Kubernetes-based app deployments, making sure they're secure and compliant. We also support security across multi-cloud environments. Enjoy all the amazing speakers and talks this year, and then join us in the Discord to find out all about Chef's new capabilities.
All right, thank you, Chef. And that is it for sponsors. Our sponsors at this moment. I'm going to hand it back over to Bridget, who will be introducing our next speaker.
Okay, thank you. All right. So, you may have noticed that this is DevOps Days Minneapolis. For those of you who are locals, you know what that means. For those of you who aren't locals, everything here is Target, and also everything here is safety and, on-demand and delivery, et cetera. And it's pretty exciting that the speaker that we're talking to, I actually tried to get Dan to come and talk at DevOps Days Minneapolis a couple years ago. Didn't actually work out, but he had a colleague come talk. It was fantastic. But I really wanted him to give us the enterprise view multi-cloud story, because many of you either work at large enterprises, or you would like your enterprise to become a large enterprise, or you vend things to large enterprises. Like, all these things make it highly relevant to your interests, that what kind of cloud choices you make. So I guess without further ado, I'd like to welcome Dan Woods to the stage so that he can come and tell us all of the wisdom that you get, and he'll talk a little bit more about his background, but we'll talk about a little bit of what you get trying to make those decisions. Because, again, as somebody who has worked for vendors in this space, will admit to you, you can't necessarily, you can't necessarily believe what the vendors say, just saying. But you can believe what your practitioners like Dan tell you. So without further ado, Dan Woods. Give it up for Dan.
Thank you, Bridget. Great introduction. Thank you so much for that. I'll just jump. I was talking to Bridget earlier today about just how weird it is to be back in person, and this is my first in-person event in close to, I guess it was closer to 2.5 or 3 years, and over basically the last year and a half, obviously everything has been virtual, right? And so I've gotten kind of used to the preparation method for a virtual talk, so this should be interesting. I welcome feedback at the end of it. Essentially we're here today to talk about what it means to run a distributed architecture in a multi-cloud configuration, and basically everything that goes along with it. Target is a very large enterprise. John Engelman, who is director of technology at Target, came a couple of years ago and talked about Target Application Platform, which is sort of the foundation of how we approach multi-cloud inside of Target. So we're gonna talk a little bit about that. I'll start off by introducing myself, which will be helpful. So in my current role, I'm the CISO and VP of Cybersecurity at Shipped. This is a fairly new position for me within the last month or so. So when Bridget and I were talking about giving this talk this year, I was actually still working at Target. So as we go through this presentation and I'm talking about multi-cloud, I am talking from the perspective of Target. And when I say things like we, I caught myself a lot in preparation saying we and us and all of that kind of stuff. Just know that I'm referring to Target when I'm talking about that. Shipped has a very, very different cloud environment than Target does. But essentially I worked in Target infrastructure for a number of years. I've been on the ground floor of building and developing out and operationalizing and taking to production a number of fairly large cloud environments that have ended up being large-scale productions. And in a previous life, I was one of the original developers on Spinnaker. Spinnaker is an open source continuous delivery platform. It's open source through Netflix, but in collaboration with a number of large organizations who are doing multi-cloud and continuous delivery and so forth. So that's it. There's links to my social media for anybody who wants to connect with me and go from there. No meeting in modern times would be appropriate without an agenda. So I've added a couple of points that we're going to go through and talk about. The first thing I want to do is I want to add a little bit of definition to the term multi-cloud, and specifically what I consider some of the configurations that often fall under the guise of multi-cloud, but you know, I think it's important for us to get some of the wording straight, at least for this conversation. Then I want to talk about a little bit about some of the ground level architectural considerations, some of the practices, the architectural patterns that need to be in place to practically pull off a multi-cloud environment. From there, I want to jump in and dive a little bit deeper into Target's hybrid multi-cloud environment. I want to talk about how Target has achieved workload mobility across clouds, how we've preserved, or I shouldn't say preserve, how we've created a constant state architecture, which I'll hopefully make sense by the end of this, and talk a little bit more about how we do data movement, which also hopefully will make sense. And then finally, I want to talk about some of the more advanced considerations for essentially what you can do when you have a multi-cloud environment, and essentially talk about where do we go from here now that Target's built all this out. Before we dive in, though, I want to point you to Richard Seroter's Twitter account. Interestingly, as I was putting this talk together, Richard did a pretty cool series of short interviews with a bunch of industry-leading experts talking about multi-cloud, what it all was, and I just really found the conversations fascinating. So if you get an opportunity, I think jump over to Richard's Twitter and you can kind of dive through his video. I think he did 8 individual videos, but they were all extremely good, so worthwhile to take a look at that. Okay, so let's define cloud stereotypes and add a little bit of nomenclature around some of the terminology. And actually, before we even talk about multi-cloud, I'm going to end on multi-cloud, but I want to start by talking about hybrid cloud, because I suspect that for most enterprises that are not yet talking about multi-cloud or whatever, this is probably the world that you live in. And I define hybrid cloud as something of a mix of legacy and modern environments. And this could be for organizations that are on a digital transformation journey, where most of the business processes are co-located in a data center on legacy technology, and then any of the emerging technology lives out in the cloud somewhere. So you have this hybrid of business critical processes living in a data center somewhere, but then this sort of cutting edge digital operation living out in the cloud somewhere. Now, some of you, like at Target, might also be in a world where there is both legacy and emerging technology inside of your data center, as well as emerging technology inside of the cloud. So that's a really interesting thing about the work that we did in Target Infrastructure, which is that we were also, in addition to working in public cloud, we were innovating inside of a private cloud environment inside of our own data center. So that was really good. And then lastly, in terms of hybrid cloud, some of you may be in a world where this is a mix of cloud and data center and edge and IoT and literally any kind of runtime that you can think of, and I quite frankly find that fascinating and exhilarating. And Target also happens to be in that kind of world as well, where it has all those considerations to go along with it. But essentially, at the end of the day, what you see here, this is the mix of configurations that I think about when I think of hybrid cloud. So next thing I want to talk about, this is a much simpler matrix, I think very easy to understand. This is what we can call single cloud. Single cloud environment is, regardless of what the public cloud or private cloud environment that you're running in, essentially your workload tenants, your workload and your data are co-tenant with one another inside of the same cloud. Your deployment operations and runtime are all designed and sort of pre-molded to understand how that cloud operates and how the service operates inside that cloud. And you consume features that are specific and non-abstract to the cloud provider of your choice. So in other words, if you're running in AWS and you're using DynamoDB, there's a great example. Jumping from single cloud, there's another facet that I call multi-single cloud. And the interesting thing is that I think that this is actually where most people are when they talk about multi-cloud. Multi-single cloud, I think you can kind of get a good idea of what this is. But this is an environment where services are distributed and deployed across multiple cloud providers, but data is co-tenant for the services inside of their individual cloud, right? So the service architecture is able to operate cooperatively across clouds, but essentially each service and its corresponding data is landlocked to its own cloud provider. When you're developing a service in this environment, you develop it knowing that your service is going to be deployed to that particular cloud, that your operations are going to need to reflect the runtime being that cloud, and that every kind of interaction that you have from service to infrastructure knows that it's that cloud of choice. And like I said, through countless conversations and a number of with a number of organizations and other folks, when I talk to people about multi-cloud, this is what they're doing, right? They've got a number of services and they're kind of split up. But I think about that differently than I think about multi-cloud. Multi-cloud, on the other hand, how I would define this is that services and data are cooperative across multiple clouds. And that is a really important distinction from the previous multi-single cloud configuration, because services and data have no practical awareness in this configuration of any kind of locality for their base runtime state, their baseline runtime state. So in other words, in a pure definition of multi-cloud, you could easily imagine a world where one day a service is deployed to AWS, the next day it's deployed to GCP, the day after that it's running on Azure, and then the following day it's running inside of your private cloud environment. This is without a doubt the hardest configuration to pull off in practice. But I hope through this presentation and conversation to give you some food for thought and talk about how essentially we've managed to do this at Target. Addendum, I'd probably add this one in. There is a hybrid multi-cloud that should go along with that. I'm not going to talk too much about that. And these definitions will probably evolve. But let's get right to the big question, right? Is the multi-cloud architecture right for me? The truth of the matter is that there's a huge operational tax for going multi-cloud. And I would say for most small to medium-sized operations who expect to remain small to medium-sized, at least for some period of time, a single cloud deployment is absolutely the right thing to do. And so much so that you can even take that a step further. While you're still in growth phase, a single cloud in a single region is probably even the right thing to do. So think about it from that. I'm not sure that there are enough public case studies of pure multi-cloud environments for me to make a qualified argument about what the criteria matrix you should follow should be when you're deciding whether or not multi-cloud is the right thing for you. But I can share with you a little bit of what our thinking was about going to multi-cloud at Target. We're always thinking about how we can preserve and improve the team member and guest experience overall. And that means doing things in a way that we can ensure high levels of resiliency inside of the environment for both the service and data stacks. And all of this rolls up under something that we call the Target Retail Platform. Generally, we think about the Target Retail platform in CAP theorem terms of it being an AP operational and architectural mindset. So if you're familiar with the CAP theorem, you have consistency, availability, and partition tolerance. We favor availability and partition tolerance over consistency at the end of the day. And that means that, you know, for us, reliability of services is pretty much the most critical dimension in our thought process around multi-cloud. And we want to make sure, essentially, at the end of the day, that any request that's coming to any of our services has a path through to completion. And that applies to the full spectrum of what I call the Target Cloud Continuum. I'll also add on top of that that we think and talk a lot about latency tolerance, which you could argue rolls up under reliability. But we think about that distinctly because we're an omni-channel retailer. So, you know, you're in the store. We have different latency requirements for requests that are coming from a register inside the store than we do for a user on the website. So we kind of have to design our multi-cloud experience to reflect that. In a little bit here, I'm going to talk about Unimatrix and edge deployments and how they all connect up with our private and public cloud deployments. But I will also briefly introduce you to an ongoing body of work inside of Target Infrastructure that we call Maze, which essentially is our next generation of edge architecture. Very, very, very light introduction. I think, you know, that is probably a conversation for the future that we'll need to build out. But essentially, it's building on that hybrid multi-cloud experience overall. You know, broadly speaking, our mindset is that essentially we should be able to complete a transaction regardless of multiple failures in the service stack. And so naturally, you know, when we're thinking about multi-cloud at Target, we're looking to run the Target Retail platform across IaaS and across PaaS providers. So that's a big thing. Cost is the next thing that we should talk about in terms of consideration for a multi-cloud footprint. And this comes in a variety of forms. Now, what I do want to say is that in a vacuum, monetary cost when considering multi-cloud is probably the worst metric that you could optimize around. Because the truth is that you can always find ways to optimize your service stack or get better discounts from your cloud provider at the end of the day. So if you're going into multi-cloud thinking that you're going to have some kind of cost benefit from doing that, that's not the right thing. But you know, Target is a large enough operation that we can actually fairly easily quantify the cost of running a workload in an individual cloud environment, whether that's public or private, and essentially work iteratively to improve that cost coefficient, which is really nice. But the cost of going to the cloud is really based off of how you do performance optimizations and stuff like that. It's an architectural consideration. It's not a monetary factor, is what I'm getting at. So meeting the high resiliency for team member and guest experience, we need to be resilient to failures at multiple levels, including within the cloud provider infrastructure. Also, that includes our network links, our storage links, and so forth and so on. Over the last several years, the architectural considerations that have gone into the Target Retail platform have made it so that we can fairly seamlessly run the same platform and data services on top of disparate infrastructure, essentially giving us the ability to fail requests up and down the stack as any kind of errors occur. And the rigor on the architectural process has given us the flexibility to move workloads seamlessly without having to redesign any of the services, which ultimately, at the end of the day, reduces our architectural costs. If you have ever worked on an infrastructure migration project in the past, you understand that that mostly comes down to how the services are written to run on top of it. So taking it from there a little bit, the main takeaways I think that I want you to have on multi-cloud at Target is that you know, Target being an omni-channel retailer, we need to preserve you know, a very good experience across our digital and in-store experiences. We have compute that goes all the way from a data center inside of every store, all the way out to a cloud presence for our digital operation. Internally, as an internal infrastructure provider, it's also incredibly important that everything that we do is resilient and latency tolerant across the chain. So we look at it through those two kind of lens. Now, some practical pieces that I think are really important to talk about. Any organization considering going multi-cloud must have two technical practices down really well, and it's CI/CD and data movement. Most companies have one or the other. Very few companies have both. Services need to be built in a way where CI/CD encapsulates the underlying runtime environment. So in other words, services should not be designed in a way that they have to understand what cloud they're going to be running in. And I think for this audience, this is definitely speaking your language, right? You can probably already imagine how you would architect a CI job to deploy one Docker container out to two different clouds, right? That's not a very big jump. The delivery of an artifact out to multiple clouds can come in a couple of different ways. A primitive implementation of this, which again for the multi-single cloud folks I see a lot of, which is essentially adding a script at the end of a CI job that pushes a container out to one cloud and then the other cloud right after that. A more robust implementation would be to use something like Spinnaker. For those of you who have not used Spinnaker before, I talked a little bit about it in the introduction there, but it is an open source multi-cloud continuous delivery platform. Multi-cloud is a really hot topic these days and right now, but we've been building multi-cloud tooling for the better part of the last decade. So Spinnaker is a very far along project, and if you're thinking about going multi-cloud, it's a really good way of doing it. I'm not going to go in depth on Spinnaker. I think there are plenty of sources that you could find on other talks for doing that. But I do think it's important to know that Spinnaker is a pretty important part of how we do multi-cloud deployments at Target, and historically it's been a big part of the TAP architecture in the past. So just to give you a really quick overview of what a Spinnaker pipeline looks like, essentially, the difference between pushing a Docker container in a script at the end of a CI job versus what Spinnaker does. Spinnaker is able to monitor the environment and notice that as an artifact is published to, let's say a Docker container is published to a Docker registry, a pipeline can be configured to observe when that's happened and then go off and run a series of steps. So in this example, you can see that a pipeline trigger kicks off a parallel job that deploys an artifact to one cloud, waits for healthy instances, disables the old server group, and then your code is up and running and it's in production and it's all safe and the pipeline's complete. The story for how we use Spinnaker in our stores environment looks something very, very similar to this. Unimatrix is what we call the environment, and Unimatrix essentially presents Kubernetes API that in turn we're able to sync out to multiple stores. This is another one that's probably too deep for the 9 remaining minutes that I see ticking in front of me. But if you Google the blog post, I wrote a blog post a couple of years ago about our motivations for building Unimatrix and what it all means. In using Spinnaker to deploy out to our stores cloud environment, essentially we do that exact same thing. We do a pipeline trigger. We deploy out to 5 stores. Spinnaker lets you put tasks in the middle where it can do things like canary analysis or other kind of metrics observation to make sure that everything's okay. In the case of the stores, we do a manual judgment to say whether we want to proceed. Once we do, we deploy out to 10, and then we deploy out to 50, and then eventually, at the end of the pipeline, we have a chain-wide deployment. It was safe. It was good rolling, progressive deployment, and so forth. Okay, so talking about the two factors that we need CI/CD and we need data movement, right? most organizations are going to nail CI/CD, and they're going to say, we did it, we're multi-cloud, right? But that doesn't actually speak very much to how we defined a true multi-cloud, which is that services and data are able to act cooperatively across multiple clouds. So that continuum of both the service deployment and the service operational footprint, as well as the data that goes along with the service, should be able to be spread across multiple clouds. So I'm going to start by talking about the target retail platform. You know, in terms of data movement, maybe not actually surprising that DevOps and infrastructure can't do too much about pulling this off in a vacuum. There has to be application and service architecture that goes along with this. So I can't go, again, another conversation that we probably can't go too deep, but I can give you an overview. And if you go and look, Joel Crabb, who's the chief architect at Target, he's given presentations over the last 3 or 4 years about Target's microservice operation and all of that kind of stuff. So he's a really great way to go off and see that. But essentially, the Target retail platform provides a way, defines a set of patterns that defines the separation of services inside the platform that provide core data, use core data, or aggregate core data at the end of the day. So it gives a really easy framework to product development teams to understand where they fit in the architecture and what constraints they have on how the data is used and how data is produced and so forth. At the very bottom of the architecture is core data, and you can see that essentially data, even though the arrows look like they're going the wrong way, data flows from south to north, right? So any requests for core data go to the core data APIs. The core data APIs in turn pull them from databases and so forth and so on. Some examples of core data in a retail environment are, you know, you can probably sit down and imagine it, but things like item, price, location, so forth. So in other words, we have a product that we need to sell. We call that an item. An item has a price, an item has a location, et cetera, et cetera. There are distinct APIs and model contracts for each of the core data elements inside of the Target retail platform. And that's really important for us being able to pull this off in a multi-cloud environment. At the mid-tier stage, you can see that we have aggregate APIs. Aggregate APIs are essentially responsible for talking to one or more core data and then giving that data back in a unified model. And at the top are the tenant services, which ultimately consume and make use of this. This is where the features live and the features come from. Now on the right, you can see a change event has taken place. And essentially, anytime that data is changed, a data change event is published out to a common stream that anybody who's holding on to a cache of data or working with data is able to tap into that stream and get updates on this. And this is a really important concept for how we do data movement across the different clouds. If anybody's familiar with CQRS or similar event sourcing patterns, this is exactly that. Yeah, one such service that facilitates high-scale data movement for us is something called Autobahn. I don't know if Autobahn is open source at this point. There's been a lot of conversations about doing that. So that might be something to keep an eye on. But essentially, Autobahn is a hyper-efficient data movement platform that enables us to represent the core data and aggregate APIs and the corresponding data anywhere inside of the hybrid or multi-cloud environment. And basically, as long as we have network connectivity between endpoints, Autobahn takes the guesswork out of making sure that data ends up anywhere that we're running portions of the Target retail platform. It does this through a variety of mechanisms, but essentially it taps into that event source and reads update events and change events and delete events and so forth as they're happening, and updates an internal. It's more. I don't want to call it a cache because that kind of dumbs down what it actually is, but it's an internal representation of that data. And then essentially we can deploy out these facade APIs that represent that API contract. So a quick look at the Unimatrix environment, what this looks like. Every store is running a Kubernetes cluster. There is a Spinnaker pipeline to deploy out to one or many stores simultaneously. And then inside of it, we have tenant APIs. And then we have the core data APIs that Audubon is responsible for standing up a facade around. All of these tenant APIs that are running inside the Kubernetes environment in the store also run out in the cloud. It's the exact, we literally deploy the exact same container between the cloud, the data center, and the store. Multiple clouds, multiple data centers, and multiple stores, I should say. Go watch John Engelman's 2019 talk on TAP. That's, if we had a lot more time, I could go into it. But a very quick representation on how that CI/CD and data movement portion matters so much to us. This is more or less what I consider Target's cloud continuum. We have multiple public clouds. We have multiple legacy data center as well as private cloud regions, and then we have a big stores block that obviously there's multiple stores. We're creating this thing called MAZE, which stands for multiple availability zones, which essentially is the next level for how we think about our edge deployments, and our edge deployments are our store environment today. So we have CI/CD and data movement across the entire spectrum of all of these things. So any service that you write is eligible to run anywhere inside this stack. So a couple of future considerations I want to talk about and want to dive into a little bit. If you go and watch John's talk on TAP from a couple of years ago, he talks about something called Pi. Pi is essentially the platform intelligence engine inside of TAP, and it acts as a broker for deployment. And it gives us a mechanism to essentially be able to granularly control the destination for a deployment. So all deployments are written to Pi. Pi in turn figures out what backend infrastructure it needs to run on. And because we have that target retail platform architecture, we're able to pull off deploying one service basically anywhere that we want to. So something we've talked a lot about in the past and that we will talk more hopefully about in the future is essentially using Pi to build a spot instance fleet, which is cool. Functions as a service, of course, is extremely promising inside of this world. There's a lot to talk about there, especially when we talk about expanding out the Audubon data model. Sorry, not the data model, the data movement model for it, and allow it to provide bidirectional updates and automatically manage two-phase commits and event sourcing on its own, which would be very nice. And then last thing to think about for this world, we think a lot about the public cloud, and we think a lot about private cloud and data centers representing our cloud and runtime environments. A new thing that has evolved over the last couple of years is that now you can run code inside of the CDN. Most major CDN providers are allowing for functions as a service to operate inside of CDN environment. I think that's incredibly fascinating. It's not something that we've had time to dig into, but I think that could be another conversation in the multi-cloud world that maybe doesn't traditionally fit multi-cloud, but that's kind of where we are. And there we are. Thank you all very much. Appreciate your time and your attention. And thank you, Bridget, and thanks to all the organizers and sponsors of this event.
Thank you so much, Dan. That was fascinating. I was particularly amazed that every Target store runs a Kubernetes cluster. We might want to be careful about telling a horrible goose that. I don't know. But in any case, thank you. All right, we are going to hear from some sponsors now. Thanks, Debbie.
Thank you, Bridget. All right, it's me again, which means it is time for sponsors. So first up, we have Raphael from Skycrafters. Come on up.
Thank you. Good morning, everyone. My name is Rafael Bocino. I work as a community manager at Skycrafters. You can find our booth in the Sponsors Lounge. Before telling you what Skycrafter is, I'm going to tell you what Skycrafters isn't. Skycrafters isn't a vendor, so we're not here trying to sell our product or service, our product. We are here to showcase our community, the Skycrafters community. Skycrafters is a community for cloud practitioners. It doesn't matter if you're new to the cloud or if you're expert on it. We have a place for you there. It's a free community, and what we're trying to do is to connect those that are new to the cloud with those that have more experience on it, but also build a platform that we can support those that are more experienced with access to editors to help you with your articles, or maybe helping you set up a webinar so you can showcase your knowledge. So pretty much a place where, hopefully, all these people combined can grow their skills together. Today, if you sign up at the booth, we're going to raffle later this drone over here. So hopefully, I'm going to see you there, and we can have a nice chat about Skycrafters. Thank you so much.
All right, thank you, Skycrafters. Next up, I have Andrew from N0.
Hey, everybody. How many of you run Terraform? I'm the guy who's been yelling at you. Do you run Terraform? Cool. Anyway, and how many of you wish your developers could deploy their own infrastructure? Nice. Thank you. So M0 is a Terraform automation and collaboration software. So what that means is we help DevOps teams automate their Terraform deployments, infrastructure as code deployments. The main use cases we solve for are teams and governance, so we can create RBAC and policies around your deployments, as well as manage self-service. So if you want your developers to be able to deploy their own infrastructure, we can help with that too. Come talk to me. I'm next to the Red Hat and Skycraft booth, and my name is Andrew. Thank you.
Thank you, M0. All right, next up, we have Ross from Couchbase.
Good morning, everybody. I'm Ross from Couchbase, like she just said. Couchbase is a NoSQL database, specifically a key value and JSON document database. It's a modern database platform built for enterprise applications. Now, you may not have heard of Couchbase, but I would guess that 90% of you in this room interact with it every day or even have it on your phone. So if you have one of these phones like this with a piece of fruit on the back of it, you've got Couchbase running on there. If you've got a LinkedIn application on your phone, you've got Couchbase running on there. If you've ever booked any travel online, 90% chance it was Couchbase running that transaction. Enterprises choose Couchbase for 3 reasons. Number 1, developer agility. Number 2, you can run it anywhere. Any cloud, bare metal, in containers, doesn't matter. And number 3, massive performance at scale. So with that said, we're talking millions of database operations per second with sub-millisecond response times, and it just runs really fast. My time's up. Stop by and talk to us. We're nice guys. Thanks.
All right, thank you, Couchbase. After Couchbase, we have Robert from Dynatrace.
Thank you. Hi, my name is Robert Stojan. I'm a sales engineer with Dynatrace. What is Dynatrace? Dynatrace is an all-in-one software intelligence platform, but what does that really mean? So what that means is we provide a number of different services, including infrastructure monitoring, application performance monitoring, cloud automation, and a number of other different services. But that's not really what makes us different. What makes us different is that we have AI at the core of our product. So we have a purpose-built AI that we call Davis. And the purpose of Davis is that it provides you root cause for things that happen in your environment. Davis isn't going to help drive your car home, but it can tell you what happened in your web or your mobile application and why it's running slow or you're having issues that are affecting your users. It's not going to beat you in chess, but it can tell you what's happening inside your Kubernetes or your multi-cloud environment. So really, seeing is believing. Feel free to come over and see us. We love demos and POCs. We're over in the sponsored area. Thank you.
All right, thank you, Dynatrace. Next up, I have Bobby from Fire Hydrant.
Hey everyone, my name is Robert Ross, but people call me Bobby Tables. I am the CEO of Fire Hydrant. So in a default setup of Nginx, that brutal 10 seconds that we all just endured is 1/6 of the amount of time it would take to actually time out. Reliability is something that impacts more than the systems you run. It truly is a business metric. So that's why we built Fire Hydrant, a reliability platform focused on incident management. Whoa. We automate your process for declaring, remediating, and learning from an incident. Fire Hydrant runbooks allow you to de-silo knowledge and automate process based on service impact. We know that incident management isn't just about the people running your services, but the services themselves. So that's why we built a robust service catalog, automatically enrich incident data and recent changes with your system. So check us out. We're over back there.
All right. Thank you, Fire Hydrant. Next up, we have Sean from Accurix.
All right. Good morning, Minneapolis. It's actually a pleasure to be in Minneapolis, especially with everything going on. And also for Accurix, this is our first in-person event, considering we started at the beginning of the pandemic. So I'm excited to be here. I'm glad it was Minneapolis. So super awesome. So a couple things about Accurix. By the way, I lead the developer advocacy team. And at Accurix, we're focused on bridging the gap between DevOps and, yes, everybody's beloved security. And specifically, we focus on infrastructure as code. And so we do this from the developer workstation through source control managers all the way to runtime. Now, we do this in a couple of ways. Obviously, we have an open source platform, or excuse me, an open source project. Our first community event, Office Hours, is tomorrow, so join up. Come by the booth, I'll tell you a little bit more. All the way to our enterprise platform. But we are here to really help our developers, our security teams really come together and make DevSecOps a reality for you and your organization. So come on by, we're giving away a Star Trek Imperial Star Destroyer. It's a joke, it's Star Wars, get over it.
All right, thank you, Accurix. Next up is Chris from Influx Data.
Hello, everybody. First of all, thank you so much for letting me speak to you today. Zoom is nice, but man, talking to real people in real life is glorious. So thank you so much for the opportunity. I work at Influx Data, and we are the maintainers of InfluxDB, an open source time series database that a lot of developers use to build monitoring solutions. To give you an example, Node actually has an APM that they've built using InfluxDB, and also Particle, where Deb works at, they also have a sensor solution that's built on InfluxDB. It's MIT licensed, which means you can use this open source project on any commercially available product that you build. So check it out. In addition to InfluxDB, we have a partner project called Telegraph, and it is a set of collector agents where you can collect metrics from Kubernetes, Docker, protocols like SNMP, GNMI, Kafka, et cetera, et cetera. But in its true open source form, you can also use it with all kinds of other time series databases, as well as a number of commercially available monitoring solutions like New Relic, Sumo Logic, even the monitoring tool from Azure. So check these projects out. You can also use it as an excuse to learn Golang because they are written in Go. So you can tell your boss you're just learning something new. Thank you.
All right, thank you, Influx. Last, we have a video from GitLab, or at least I hope that's what's up next. Yes.
Hello, thank you for attending Minneapolis DevOps Days. I am Philip Osorg, Senior Strategic Account Leader at GitLab. Now more than ever, enterprises are looking for a competitive advantage in this fast-paced digital age. In order to achieve that advantage, enterprises must get their software right and deliver applications quickly while also not compromising on security and compliance. Welcome to GitLab, the complete open source DevOps platform delivered as a single application to help reduce toolchain complexity, deliver better products faster and more secure, all while increasing operational efficiencies. GitLab is trusted by more than 100,000 organizations worldwide and helps teams collaborate by bridging the gap between development, security, and operations teams. GitLab believes in a world where everyone can contribute, so we invite you to attend to GitLab Commit virtual event on August 3rd and 4th. Thank you, and have a great day.
All right, thank you, GitLab. And let's have a round of applause to all of our wonderful sponsors. All right, and be sure to stop by the sponsor hall or Zoom, Slack, get those questions answered, or put your name in for a raffle. Thank you.
Okay, awesome. So I'm really excited to tell you that now we are going to hear about Kubernetes. Oh, wait. Actually, we're going to hear about Starfleet. So Tess Flynn has some amazing Starfleet / Kubernetes stuff to share, and I can't be more excited to hear about it. Give it up for Tess.
Good morning. This is engineering. I need more power. Kate's operators to power your Starfleet. Are there any note takers in the room? If there are, this presentation is already online at github.io/ it's at socketwench.github.io/engineering-I-need-more-power. Give me a thumbs up if any of you have got that down. We're good? Okay, cool. Okay, so you might be wondering, who is this weird person in front of you? Do they get that excited when they have a boarding pass for a business trip, when that was a thing? The answer is, I'm Tess Flynn, otherwise known as Socket Wench. That's Wench, not Wrench. I am a developer, blogger, and educator, and a DevOps engineer at 10.7. 10.7, we make things that matter. We're 100% remote, but we are headquarters in Minneapolis. We do a number of different services, from strategy, design, and development. Also, we do support and maintenance, specializing in Drupal and WordPress sites. We're also the creator of Flight Deck, a Kates-powered hosting and local development solution, which is 100% open source. Give us a hi at the wonderful humans at 10.7. So, we know how it is. You're just there with your laptop, chilling in main engineering, checking on your warp core and your antimatter pods. Meanwhile, you and your crew are spiraling down to planet Psi 2000, also known as Planet Impending Operational Disaster, population U. But then the comm panel activates, and it's the captain saying, "Engineering, I need more power." And you have to get this depressed look on your face, and you say, "I cannot do it. I got to have at least 30 minutes. Wait, how long is this talk again? "Engineering, I need warp speed now." And here's the problem. Us as operational people are going to have to do a number of different things to interact with our target application, which relies on our cluster. We're going to have to work with Kate's definitions. We're going to work with supporting applications which live inside of our cluster, and external APIs in order to scale up our application. And it's a lot of work to deploy. But what if we were to take all of that knowledge, and take the human being out of the equation? And we take all of that knowledge and we put it inside the cluster in the form of an operator. So what is not an operator? Well, it's not a product, it's not an API, or a library. Let's look at what an operator is. So we have our operator, and we give it a CRD, a custom resource definition. That operator then can turn around and make base Kubernetes definitions, such as stateful sets, deployments, daemon sets, and so on, create pods directly if necessary, or work with external APIs. This is actually only one of the possible cases, but it is in fact the most common. You will see this again and again and again when you work with operators. The thing is that an operator is a pattern. It is a resident privileged container which watches for CRDs and performs actions in response to those CRDs. A custom resource definition, a CRD, is a Kate's kind that you define. It's going to allow you to model just the structure necessary for your application, rather than all of the other boilerplate code necessary to make it run in Kubernetes. That simplifies things quite a bit for you. In order to make operators, we can use the Operator SDK. It is a framework to create operators. It is open source, but it is sponsored by Red Hat. You can get the SDK either through Homebrew on macOS, a GitHub release if you want to go the manual route, or if you're on Linux, you might want to check your system local package manager, as it might already have it available for you. You can find a complete list of the installation instructions at stk.operatorframework.io/docs/installation. What other dependencies do you need to install the operator framework? Well, you're going to need kube control and Docker desktop. You're going to need Golang. If you're going to work with Helm charts at all, you'll need Helm. You'll also need any Ansible dependencies to write an Ansible-based runner, which is what this talk is about. Ansible, Ansible runner, and the OpenShift Python client. All right, we have it installed. Let's make a project. So, in order to initialize that project, we're going to do this command operator SDK init -- domain, some domain name, some list of plugins. Cool. What's that domain? Well, the domain is not necessarily a web domain. It's actually a namespace for API definitions. SDK calls it an API. It's actually really a kind in Kubernetes. So choosing a domain, personally, shorter is a lot better because the fully qualified domain name for your kinds is going to be kind.group.domain.tld, and it's a lot of stuff. So you might need to play around with this command a few times to get something that looks great to you. How do you choose? I personally like saying the domain is going to be your organization, and also the group is going to be your application. Now, if you're a particularly large organization, it might be subunit instead of organization, so your mileage may vary. What about that plugin switch? That plugin switch specifies the runtime environment for your operator. That can be one of three that's included out of the box: Go, Helm, or Ansible. Golang is going to be the most flexible, but it is the most difficult in order to implement. It's best for new from-scratch operators which have very complex applications. On the other end of the spectrum, there's actually Helm. And Helm is actually the easiest. However, it is the least flexible. It's best when you have an existing chart that you need to add CRD support to. And then there's Ansible, and I love Ansible. It's more flexible than Helm, however, it is less complex than Go. I consider it the middle ground. It's interpreted, not compiled, and it has built-in modules for Kubernetes databases, cloud APIs, and a whole bunch more stuff. It's kind of a batteries-included product. And you might, in fact, already be using it. When should you use the Ansible plugin? Well, if you have an existing CI script that runs on a Jenkins server or GitLab CI or Circle CI or any CI server that invokes Ansible, you can port those existing scripts over to an operator and then power them up with additional CRDs. Or if you have a simpler application which needs stateful changes like a database cluster. When you initialize your project, I suggest you initialize it in a subdirectory, path /my-operator/source. And the reason why is because this will aid in build automation much later. Here's what that directory layout looks like. There's a lot of stuff in here. The config directory is going to have CRDs, schemas, samples. You have the Docker file, which is going to be for the operator container. And then you have a bunch of Ansible stuff. If you actually have worked with Ansible before, that's exactly what that looks like, completely familiar to you. And then finally, there's the watches.yaml, which is going to be your SDK configuration. All right, now we can make a kind. So how do we do that? We're going to do operator SDK create API -- group my app -- kind my kind -- generate role. What's this do? It's going to create a CRD template, it's going to update the watches.yaml, and it's going to create an Ansible role provided that you specify -- generate role. What about this CRD schema? One is created for each API, and it's going to be created in config/crd/basis. Now, the structure for this particular schema is actually based on the OpenAPI version 3 schema, like any other Kubernetes custom resource definition, and it has an accept all schema by default. It's good for development, but please don't launch with it. This is actually what that schema file looks like, and the important field here is actually this x Kubernetes preserve unknown fields line, which allows it to accept all by default. Okay. Now, let's actually write the code for our operator. So how do we make sure that we have the proper access to Kubernetes in order to create definitions? Actually, the operator framework does it for us. The operator relies on a service account and a role, and you can actually find the configuration for that in config/crd, and then there's a different file for role binding, role, and service account. The default permissions allow you to work with your CRDs and common Kubernetes definitions, again, stateful sets deployments, replica sets, all of those normal definitions. However, it doesn't include, for some reason, config maps. So you definitely want to make sure that you only add the permissions that you need and remove any that you don't. Otherwise, Honksly, the space goose, is going to chase you all the way from the galley to the programmer's restroom. What about the input to your role? It's going to pass you the CRD definition that's created, deleted, or edited. And it's passed as an Ansible variable. Here's what it looks like. For the metadata values, you're going to have it in an enclosure, Ansible operator underscore meta, and then the metadata values. It's not shown here, but labels also show up here as well. This enclosure, the Ansible underscore operator underscore meta name, is different in older versions of the SDK because of a naming conflict with newer versions of Ansible. What about the spec values? Those are also exported as Ansible variables, but they're exported as top-level Ansible variables, which makes it a little bit more confusing. It's actually converted for you from YAML standard camel case to snake case or rope case. PHP programmers already know all about snake case. That sample CRD that you want to create, it's going to, let's say we have a sample CRD. Here's what it looks like. It's going to be for a MySQL cluster. It has three variables, MySQL admin secret, MySQL reader secret, and size. Note the camel case. And then when you actually do that in Ansible, it's going to look like this. And you'll notice now they're all in snake case. MySQL underscore admin underscore secret, MySQL underscore readers underscore secret, and size is just size. All right. How do you create or update a Kubernetes definition inside of Ansible? It's actually pretty easy. There's the K8s module. And since your local cluster is already authenticated, you don't need to pass a kubeconfig environment variable or any other weird stuff. It's already done for you. Here's what an actual creation statement looks like. You'll see that we have the K8s module here. Here's the definition, and we're making a service. And we can template it all out as we normally do with any other Ansible, including default variables or transformations or anything else, all the cool Ansible stuff. Okay, how do we get this onto the cluster? Well, first we need to build that Docker image, then we're going to need to push it to a registry, then we're going to need to push the definitions to the cluster. First, we need to configure the image and tag. That's going to be set in the make file. Look for a line that starts with img. Then go ahead and set the full registry URL, and then your operator name, and optionally a tag if you want to set a tag. Then you can build the Docker image. You can do make Docker build in the source directory of your project. This builds and tags the image. It's the equivalent of Docker build and Docker tag. Then you can push it to the registry, Docker log into your registry, whether it's Docker Hub or Quay.io or your personal registry. Then go ahead and do a make Docker push. That just runs Docker push. And then you can apply the definitions. The final line to do that is going to be make deploy. And that's going to template up all your CRDs and everything else necessary to scaffold and run the cluster and run that through customize and deploy it to your cluster. Okay. So how do you deploy a CRD? Well, you can find a sample in config/samples. You can edit that sample, and then you just use kubectl apply-f like you normally would. And what that looks like then is that you have your CRD that's going to be passed to the operator. The operator can then create one or more base Kubernetes definitions. This results in new objects. And then the cluster goes, yep, we made some new objects, and it tells the operator that that's what we did. And then the operator says, changed. Change is particularly important for Ansible. That means that the state of the infrastructure has actually changed. And that's going to become very important in a second. So this is what's called the deployment run. And the deployment run creates new Kubernetes objects, deployment, stateful sets, pods, and so on. All right, that's great. So what? What is it, Mini-Me? Why is this running twice? Oh, yeah, I forgot about that. So after the deployment run, it runs again. So you have a CRD. It gets passed to your operator just like before. The operator makes a number of Kubernetes definitions just like it did before. But because it's the same data, it results in the same objects. The cluster says no changes were made. And then the operator goes, OK. And if you've worked with Ansible before, OK is good. It means that the state of the infrastructure did not change. This is called the reconcile run. The reconcile run validates the current configuration against the operator, and it means, and you must not have any changed tasks within your code in order for that to run successfully. This means that if you do something as simple as create a temp file, that requires a change status because the state of the infrastructure changed, and thus you get something called a reconcile loop. And that's really bad because then your deploy will never, ever finish. How do you view the results? It's actually really easy. Just go ahead and kubectl edit the CRD that you already deployed, then look at the status.ansible results section of that definition. So here we have an example of that, and it's looking pretty good. Changed 0, failures 1, that's less good. Okay, 9, unknown playbook failure, huh? Well, that's not real helpful. What the heck is going on here? How do we actually debug this? Well, what we can do is we can tail our operator container, specifically the manager container within the operator pod. So we're going to do kubectl logs-f operator pod-c manager, and then we can use that to look for the output of our deployment or reconcile runs. And this is where you want to look for deployment loops. Now, in this particular deploy, which I did just Monday, you'll actually notice that here in the output of the manager, we'll find out that I renamed a playbook, and I forgot to change it in the calling playbook, and that was the problem. So there you go, that was the problem, and now we can fix our code, redeploy it. So how do we clean up so that we can redeploy? We can do a make undeploy, and then we have to worry about our finalizers. Right now we haven't set any on our CRDs, our custom definitions, but that can cause the make deploy to hang, as we shall see later. Okay, that's great and all. We're just using Kubernetes to make more Kubernetes, but what if we want to do something else? This is what's called a stateful change. A stateful change is any non-Kubernetes resource. That's going to be any on-cluster applications or external APIs. There's no reconcile run when this happens because no K8s definitions were created, so it's not needed. So what happens then, you might have a problem with writing your role. You might need a piece of dependent information. So you get your CRD, it's passed to your operator, and the CRD is saying, make this database on this cluster in this namespace. And the operator is going to go, hey, how do I log into that cluster? And of course, the CRD doesn't care, and of course, the operator can't do anything as a result. So how do you look up definitions within your operator? Well, there's actually a K8s lookup in Ansible. And your local cluster is already authenticated just like it was with the K8s module before for creating definitions, same deal. So this is what that would look like. You have your CRD, it's passed to your operator. The CRD contains information to spin up a new database cluster. The operator does a lookup. It gets one or more K8s definitions resulting for that particular database cluster. It can get the login secret name from that definition, look up the secret, do another lookup, and then it can query the underlying database pod using the normal, completely boring MySQL_DB module that Ansible provides. And then you get a new database. It's pretty cool. Here's what one of those lookups look like. It's actually really, really long, but you can see it's kind of boring. You have your K8s lookup, the kind is my kind, namespace, and then resource name, and you can use variables for all of these, just as you would expect. Resource name is actually slightly different in newer versions of Ansible. It used to be resource. Again, there's a naming conflict, so that's going to be another hazard you'll have to deal with. So where should you use these lookups? You can use them inline in any Ansible template that you need to use. You can also set task-level var statements if you need to get, say, a default, or you can just use a boring old setFact task. The reason why setFact is OK is because it always evaluates to OK, not changed, so it does not create a reconcile loop. What happens, though, when you have a failed lookup? Well, in the K8s lookup module, what happens is that it returns an empty list, not an empty variable. And it doesn't fail the run when that lookup fails. So you're responsible for the error handling. This is the code fragment that I came up with that actually seems to work pretty well for detecting failed lookups. The name of your variable, piped it through default to return an empty list, and then check to see if the length of the list is less than 1. How do you inform the user if you have a failed lookup or any other failure within your operator? You could use the fail module. It causes the run to fail immediately, and you can set a message to aid debugging. And this message ends up in the CRD status. So you do want to use this module. So here's an example of what that looks like. You can actually see there's a set fact here. We're actually using a var statement here to actually get a default. And then we're going to use the fail module to set a particular nice error message that people can read in our CRD, and then we're going to check that against the length of that query. All right, cool. What about deletions? You need to delete that database. Well, the operator framework does not handle that for you like it did for Kate's definitions. So you actually have to handle it yourself. So this is where finalizers come in, and every ops person who's ever had to deal with a stuck delete already is groaning internally. So finalizers run when deleting a Kate's definition, and it's specified in the operator framework in watches.yaml. In Ansible finalizers, you actually can use an existing role, a playbook with custom vars, but my recommendation is to use a new role or playbook. A role is recommended. You can separate it from the creation role, and then you have a separate delegation of responsibilities compared to creation. Now, this does result in some code duplication, particularly if you need to do a lot of lookups. However, it is a lot easier, and you don't have weird conditional statements as a result. Then, how do you create the role? When we actually created our API way back at the beginning of this talk 20 minutes ago, we actually let the operator framework do it for us. However, when we're creating a finalizer, we have to make that role manually. So we have to init it manually, and it's best if you name it after the creation role. And this is what that line looks like: Ansible Galaxy init, path to my operator, and then all the way through the rest of the path, with the name of the creation role _ finalizer at the end. Then you need to update watches.yaml. This will add the finalizer key to the particular API that you're deleting. Then you point it at the new role. Here's what that looks like. You'll actually see the first few lines there, your version 1, group, kind, and role. That's created from Operator SDK create API. And here's the stuff that we added manually: finalizer, then under finalizer, name, which is going to be the name of the finalizer, and then role, which is the name of the role in the roles folder. Now, when you do an undeploy, you can actually have some problems, because the thing is that when you do make undeploy, it kills the operator first. This immediately creates a make undeployment loop, and it means that the make undeploy never returns. So you can either delete your custom resource definitions manually, or you can go in and set each one of the finalizer sections for those CRDs to an empty list, and then the delete will complete as normal. Sometimes, however, operator framework's great, but you need extra stuff in order to do stateful changes in your infrastructure. You need extra libraries, extra applications, extra commands, and those need to be in your Docker image. So you need to modify the image. So it's really as any other Docker modification you might have done in the past. You can update the Docker file. The image for the Operator SDK is based on the Red Hat Universal Base image, which is admittedly a little weird. How do you add libraries to this? It's actually very straightforward. If you've ever worked with Red Hat or CentOS, you can use pip for Python-only libs, or you can actually use yum for everything else. Special thanks to Jeff Geerling for this tip. Here's actually a modified Docker file. You'll notice that this part right here is from the original SDK. Then we actually are going to add stuff to it, so we change to the root user. We're going to download MySQL, and then we're going to install the client and Python libs, and finally switch back to the Ansible user. Okay. So that's all fun, but we definitely are doing way too much work. We would rather just activate the emergency engineering hologram and have it do all of this work for us. So how do we do that? Well, the directory layout helps us here. That source directory makes this a lot easier for us to implement. So first of all, that Docker file, let's look at it. It's nothing fancy. It's a public base image that you can access from anywhere. There's no complex build chain or weird variables or anything. It's really just Docker build and you're done. So you can build it like any other container. Docker build, Docker tag, Docker push. You can actually put this into Docker Hub with an automated build, Quay.io, or any of your own CI systems necessary to build the container. Here's actually the rules that I used on Docker Hub. As you can tell, these are really boring rules. We have the main branch, which with latest tag. We have a numerical tag source with a source ref for the Docker tag. The Docker files in the root of the directory. The build context is going to be in the /source directory. Boring, 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 as you totally would have expected. What about replacing the make deploy, though? That's a little bit more complicated because that just went to the cluster and things happened. We don't know what it did. Well, there's two different options to getting those definitions onto your cluster. You can use a conventional manifest, or you can use a Helm chart. How do you get that manifest, though? You need to capture the customize output from the make deploy. So we're going to hack the make file. So we have our make file here. You'll find this line in it, which is going to say deploy customize. There's a bunch of gobbledygook. But way at the end here, we actually see the critical line, which is pipe kube control apply -f dash. And that's actually what we want to replace. We replace that with this. We pipe it to a file. There's your manifest. You're done. What about if you want to use a Helm chart? Now, Helm charts actually have a number of different advantages over a traditional manifest. It's often used to deploy operators because it has templating, versioning, and third-party integrations such as DigitalOcean Marketplace built into it. So that's actually a lot of advantage that you can use there. In order to create your Helm chart, you can actually use that customized output, break it up into several different files according to the standard format for Helm charts, add Helm labels. This is the most difficult part because you do have to add tons of templated labels that Helm requires. So you'll get to know Helm a bit. And then afterwards, you can add that to your project. My recommendation is to actually add it to the charts directory under your root directory, and then the name of your chart after that. Why charts and not chart? Well, you'll see that in a sec. Okay, so how do you distribute all of this stuff? Well, you need a Helm repository. And you can, this hosts your chart tarballs by a particular version. You can actually get GitHub to act as a Helm repository. What happens is that GitHub Pages will host the repo, and then the actions will build the chart. How do you configure Pages? It's actually fairly straightforward. You set the GH Pages branch as your Pages branch. Then you empty the branch of all code. You don't want anything in there. Then you need to set up an action. I actually found a plugin online, Helm-GH-Pages, which builds Helm charts on a deploy. Then you can commit that to a GitHub action file under the .github directory. One important detail that I found out is you should override the version in your plugin configuration for this GitHub action. This way that you can set the app and the chart version by the GH Pages tag, and this will ignore the default version that's in chart.yaml, which is 0.1 by default. This is actually what that looks like. There's a lot of stuff in here, but the important parts are going to be the app version and chart version, which is going to default to the tag that we're going to commit, the charts directory, and the branch name. And that's all we need to worry about for that particular workflow. After that, the deployment's actually fairly easy. You're going to commit to the GH Pages branch, you're going to tag it, and you're going to push it. Hub builds the image, and then the action builds the chart. And that's it. Now you have an operator with automated builds, running Ansible code, ready for public distribution. If you want some further reading, there's a number of different places you can go. Introduction to Operators, the Operator SDK, Ansible Quick Start, Helm chart getting started, GitHub as a Helm repo, which is, tells you how to use that GitHub action to make a GitHub Pages into a Helm repo. And if you want to know how I built this ridiculous Raspberry Pi powered tricorder, you can see my blog post there at the bottom. I also want to give a special thanks for this event for having me here today, 10/7 for sponsoring my time here, and my wonderful patrons on patreon.com/socketwench. Thank you. You can find this presentation on github.io.
Tess, that was delightful. Oh, next up, I suppose, chat with Tess to find out exactly what that tricorder can do. I want to see the Raspberry Pi components. That sounds great. So yeah, you now have a half-hour break. Go visit the sponsors. Be back here at 10:50, so you can find out how to use the ideas behind hackathons to onboard new developers, empower your organization, get people learning. Very exciting. So we'll see you back here at 10:50, and visit the sponsors. Enter those drawings. Thanks. It looks like people have gone and visited the sponsor hall, which is great. I know a couple of them are heading back, and we also have folks on the live streams clamoring for us to start again, which is awesome. As folks come back in, I just want to quickly let you know we have this talk, we have another talk after this talk, and then we have the break for lunch. Lunch will be on your own from 12 to 1:30. At 1:30, we're going to meet back right here to put together the open space attendee suggested breakout schedule. Like, you bring your ideas, it gets made into a grid, you get a circle of chairs in another room and go and have the discussion sort of thing. All right? So after these two talks, then you go do lunch, then you come back and do that at 1:30. And then at 2:30, the sponsor raffle for all of those great items that you just went and put your names in for is going to be right here on the main stage. So just giving you a little bit of a picture of what's happening here. Okay. All right. So next up, I hear so often from people about how people are trying to motivate people to write documentation, or they're trying to motivate people to learn something new, or they're trying to help onboard new employees. And it's always a challenge. And it ends up being, oh, all right, cool, we just hired, it's great, but now we have to get people to learn and work together. We need to try to get everybody to, level up their game, but you can't just give people a website and say, hey, try to learn something, right? So I was so excited when I talked to Caroline Karanja, because I'm really impressed with the work that she's been doing to get people trying things, collaborating with each other, just learning those new things and putting them into practice right away with Hack the Gap. So without further ado, I'd like to welcome Caroline to the stage and have her give us some insights into how to use hackathons to help people do that onboarding, learning, leveling up, and just, getting everything that you want in your organization. So welcome, Caroline. Give it up for Caroline.
Thank you. I brought my glasses thinking I'd need them, but I think we're good. All right, let's see. Hey everyone, my name is Caroline Karanja, and I'm here to talk to you a little bit about hackathons. I know that hackathons might be something that you all are somewhat familiar with, but just wanted to give you all a deep dive and show you how you can use them within your teams to really elevate what you're currently doing. But a little bit about myself. As you can see, a lovely photo there. I consider myself a tech creative based out of here, Minneapolis, St. Paul. I also happen to be a children's book author. I'm really passionate about how we make technology and computing in general more accessible and more available. And I just thought one day it'd be really fun to write this from the perspective of like a first grader. And so I ended up with 4 books out of it. So just a little random fact. In addition to Hack the Gap, I also run a company called Guided Pulse, and we're really passionate about helping employers and organizations infuse diversity, equity, and inclusion into their work, not just by talking about it, but actually having specific action plans that tie into their organization's culture and the way that they already work. But I'm here more specifically to talk to you about Hack the Gap and hackathons and how you can leverage this within your organization. But a little bit about Hack the Gap first and foremost. We're focused on increasing the presence of women and non-binary techies within our broader ecosystem. We do this in part by hosting hackathon events. These are some that we put on ourselves, but then we also started doing this thing where we have it as hackathon as a service and work with organizations to partner with them and co-host their own hackathons or hackathons around their products and new technologies that they're launching. And so again, I'm here to talk to you about, our hackathons, the secret sauce. And I'm specifically going to focus on 3 ways that you can utilize hackathons within your organizations. You can use them as a way to facilitate employee or participant collaboration. Bridget mentioned that that some people might be thinking about, well, how do we onboard people onto our team? How do we get people to know each other and work together? We're going to talk a little bit about how this framework is really well positioned to help you do that. Hackathons also are a really great way to innovate and address product challenges. And in fact, this is part of the core foundings around what hackathons were created to do. And then we'll also talk about the ways in which hackathons can help you better understand the ways that your customer and users are using your product. So that way you can build something that's really addressing certain pain points within the service or product that you're offering. So what is a hackathon? So hackathon is a combination of two words, hack and marathon. And it was first used in 1999. There's kind of a debate around who used it first and where. But as far as I could find, it was used in both Canada and California at about the same time in 1999. But the concept itself dates back to the 1970s. And in the 70s, it was used in these like demo day. It was really about competitive programming, and it really was bigger in like the video gaming space, the multiplayer video gaming space. But in general, hackathon is just a rapid innovation process. You get together very quickly, you go from idea to something that's designable or even built in a short amount of time. It also really forces people to focus on collaboration. Hackathon is really only possible when you have people who are working together and either compromising or co-building in order to make the product or the end deliverable possible. And some of those outcomes of that end product could be designing a solutions, it could be designing a new framework, all sorts of different things, but you need to know what the end deliverable will be. And so what's our take on hackathons? Well, we see it as an opportunity for people to go from idea to solution in a very, very short amount of time. So within the span of like 48 hours, you can go from, I've never met you or you or you, but at the end of those 48 hours, we go from identifying a particular challenge or opportunity and building something that we can showcase and present to other people. We also see it as a way to collaborate and empower everyday people to be able to take their ideas to that next level. So you can take something that you've been thinking about forever and actually build it within a short amount of time and have the opportunity to test it out. Hackathons are also a space where people can get an opportunity to connect with each other, to network, to build relationships, and more importantly, to grow their skills and take their skills to the next level. I'll share with you a little bit of a story about my first hackathon experience. This was pre-Hack the Gap, and I attended, I think about 3 or 4 hackathons before Hack the Gap. And I don't know why, but on the weekends I'd just be like, oh, I wonder if I could just go and like collaborate with strangers. So I was in Madison, Wisconsin at the time, and I signed up for this like 3-day hackathon, and I showed up, met a bunch of people I'd never met before, worked with a team with 2 other guys. I was the developer on the team. And it was really fun to go, again, from I'd never met these people to by the end of those 3 days, I knew so much about them. We had figured out how to work together, so it also worked out that we're a team that really collaborated. But I also saw some of the best and some of the most challenging qualities out of people and out of their teams really kind of come up to the top within that short amount of time, because there's also a lot of pressure in trying to build something, and it's also a hackathon. Part of it is that it's slightly competitive within all of that. But that was such a good experience that I kind of kept doing it over and over again. And once I found Hack the Gap, I really just kind of stuck to this as the place where I would keep on doing that and growing my skills. And so as you're thinking about whether or not hackathons are your secret sauce, let's talk a little bit about the process, and hopefully you can see how this process can help facilitate some of the things that you're looking to do within your teams. So first and foremost, you want to choose a focus area. So this can be a theme. So your theme might be, well, we want to address challenges around access to education. Or your theme could be that we want to do something interesting for employees for the next week. The theme can be really as broad, and the focus area can be as broad as you need it to be. The main thing you need to focus on is what's the glue that's holding everyone together. What makes one team and another team, even though they're working on something different, feel like they're still working towards a similar goal. And then, of course, you want to think through the timeline of the projects or how long they have to make that happen. And as you're putting together the teams, you want to think through who are the participants. Do you just want to have your internal employees, or do you also want to engage community members, or again, your users or your customers or other people within your general ecosystem to be part of that process? It can be a really cool way of expanding your brand, of bringing some more humanity to your organization, like people being able to see each other. It's a really great way of having people connect in all sorts of different ways. And then, of course, as they're thinking about potentially presenting, who's the audience? Is this something that you want to share with, maybe your development team wants to share with the product team as cool ideas they've been thinking about? Is this something that you want to share out with your marketing team? Is this something you want to test out and share out with the broader audience? And then all of this, I think it's really important to have a purpose. The best hackathons and the best collaborative events are ones in which there's a shared purpose. And so you really want to create a space where people can identify something beyond just their skills and what they're bringing to the table, but a passion that they have around a particular topic. And then within the teams, it's important to understand and see how the different roles can come together. So in order for a team to be successful, do you need a designer, a developer, a business person? What are the key components that are necessary to make a team really be poised for success? And this is going to look different for each type of hackathon that you have. And then, of course, the deliverables. And this is really all about making sure that, again, everyone is set up for success. What's going to be the final product? What's the goal? And how will the teams know when they're, quote unquote, done? Because otherwise, you can have folks who never get started because the idea is too broad, or the deliverable is too broad, or folks who just keep working and never get to the point where they feel comfortable enough to present. So you want to make sure you really define what that done looks like. And this is something that's just kind of fun, but really, how do you gamify the process so that way it's interesting? What's the incentive for people to keep on working through and continue to work on the project? So as you're thinking about how you can leverage hackathons, these are key components to make sure that you build something that is going to be intriguing and engaging to your participants. And so for us, this is in 2019, pre-COVID, but for us, this is kind of how the initial process would start. People would share out a bunch of ideas. Folks would go around and vote with different stickies. And then once the ideas that have the most votes or potential engagement have been identified, then people would come together, form a team around that particular idea, and start to get to know each other. So a lot of these people had never met each other an hour prior to this photo being taken. And now, there's some sense of camaraderie. So then you go from that part to actually building, connecting with each other, learning from each other. You can have folks who may never have tried out a framework prior to a hackathon see this as an opportunity to do just that. You can really kind of take this concept and push it beyond its boundaries. So for example, if you have like a team member who's in your product team who's always wanted to try something in testing, a hackathon is a great opportunity for them to try out some of those new skills and to test out what it would be like to be in other divisions within your organizations. And then after they've built something, you present your idea to your colleagues or just the broader audience. And this can be tied to things like prizes and other ways of kind of leveling up that experience. But in the midst of all of that, I think it's always cool to infuse fun elements into it. And so one of the things that we found to be just really enjoyable is inviting other people, potential vendors, to come and join us and share what they're doing. So this is an example where we had Spinning Wild, which is a cotton candy company, come and spin for us. So they were making just a bunch of cotton candy while people were waiting and presentations were going on. We also have had, for our virtual events, an organization called Coconut Whisk, and they are focused on gluten-free desserts, essentially. So like cupcakes, pancakes, all sorts of different types of baked goods. And they showed us basically how to use their product to make a really delicious breakfast that is also gluten-free. So just infusing other elements that make that whole experience a little bit more holistic and enjoyable. So going back to those three key things that we can use and leverage within the hackathon process, I kind of just want to highlight 4 core areas for each one of them and talk a little bit about that. So first and foremost, when we're talking about facilitating participant collaborations, you really can use this as an opportunity to host teams that are coming from different parts of your organization. So when you think about, especially some of these large organizations, some folks have never met each other. Departments never connect outside of maybe a manager level or a certain level of the organization. And that can make it really hard for people to feel connected to how their work is leading to the end product, or is actually connecting with the consumer or the user or the customer. And so by having a hackathon where you can have teams from different parts of the organization, it's a really great opportunity for everyone to see how their work might impact another department or another team, and therefore build some empathy and camaraderie with one another. So we see this as a really great way of crossing some of those bridges in a way that's more organic, more fun, and can lead to much deeper relationships across team members and across teams more broadly. Because we know that when teams don't really work together, when one side of the organization does not necessarily see how their work might impact another part, that's definitely going to show up in one way or another in the products or the services that are being created. Another piece is that this is an opportunity to encourage creativity beyond everyone's day-to-day work. So because it's a hackathon, you can choose what role you want to play, and you can really choose what new skills, or you can stick to just deepening your current skills. And it's a really great way to kind of expand beyond what you're currently doing. And oftentimes, within our day-to-day work, we don't always get a chance to do that, right? We don't always get a chance to try something new within our marketing departments, or try something new within our specific engineering teams. And hackathons are a great way to do that in a way that's completely low risk, and in a way that employees and participants are not necessarily going to feel a lot of pressure, but just a chance to try something else. This is also a great way to introduce a new framework or language or a new way of doing things within your team in a way that's more confined. And so by that I mean that you can either test out the ability to try out maybe a new like a new launch product or service, or to try out a new framework within what you currently have, and just test some of those things out in a very low risk type of environment. Hackathons are a great way to do that, and a great way to just see how your team might engage with that new process. And of course, process development and infusing new processes sometimes can take weeks, if not months, and then sometimes it works, and then when it doesn't, it's the worst, because you spend all this time and energy in trying to get buy-in, and if it doesn't work within your team, you've lost a lot of time and energy. And so a hackathon is a great way of testing it out within a short amount of time, gathering the feedback that you need to either move forward or improve on what it is that you're currently trying to introduce within your team. And by the way, that can be part of the theme that you have. So maybe your theme for your next hackathon is using a certain framework. The other piece as well is that this is a great way for teams to connect, especially right now as organizations are trying to figure out whether or not they're going to be hybrid or virtual or in person. Hackathons are a good way of just reconnecting people, but in a way that's still going to work within whatever your workplace environment looks like at the moment. So hosting hybrid or virtual hackathons can really still give people that feeling of being together and staying connected. And then of course, it's always good to have incentives to drive that collaboration. But also hackathons, part of it is that it's a little bit competitive. You want to create a space where people can really showcase their talent, showcase what they're all about, where teams can try to figure out how to bring the best and most innovative solution to the table. And the more freedom and creativity they have to do so, I think you'll get some really interesting results out of the types of projects that come out of it. But that healthy competition is part of is part of that hackathon process. And again, especially in a low-risk type of environment, like being able to build something within a short amount of time. So now to the next process around, the next piece around how hackathons can be used to address product challenges. And of course, this is something that a lot of us are always working towards. And I do use the word product broadly, so product or service, whatever it is that you're offering. The first thing is that you can use it as an opportunity to address very specific product challenges. So you could have a hackathon that's just focused on a bunch of bug fixes, if that's what your team wants to do, or maybe addressing some of the biggest hiccups and gaps within your product, your delivery method. It's a great way of just picking that particular focus area and seeing how you can go about creating an innovative solution that can be focused on just that part. And these product challenges can also be about, whether it's building a new feature, but then also understanding, using your product engagement data to understand where some of those challenges can be. This can also be a great place to consider building new features that are driven purely by the team. So oftentimes we have, whether it's a new feature or a new product, might come from different parts of the organization. But I think it would be a really cool idea to ask the team itself and say, hey, we have a chance for you all to look at our product and think about what you would want added in there. And you might get some really cool and interesting ideas out of this as part of the way that you think about product development. And so having those new features driven by your team, you could get a completely different angle, because these are the people who are usually going to be building your team, especially if they're the developers. Oftentimes they're building and not necessarily having a say in what it is that they're building. It can also help you take a more rounded approach to the product. And by this, I mean having a team that incorporates different parts of the organizations or different people that interact with the product or your customer or user be part of the hackathon team itself means that you can have all those different perspectives, again, within a short amount of time to create a very specific item. And you can also build something that's different or interesting, or just use it as an opportunity to give back to your community. So this might be a cool way to do some open source type of work that connects back to your product. It could be some really interesting lead generation opportunities. And so just thinking about it in that way can also help you see the value that comes out of giving people that opportunity to just kind of do something that's a little bit different, but really in their own hands within their own sort of creative outlet. And something else I want to add to when it comes to using this as a chance to address your product challenges, you can take a look at your backlog that you have and what some of the tickets that you have and see if there's certain themes. And those could also be the themes that you can use as the general theme for your hackathon for the teams to focus on. And as I mentioned, this can also be a really great way of understanding the ways that your customers or your user is using your product or service. And so you can focus on pain points that's focused on customer feedback that you're getting all the time. Take a look at your social media, see what people are saying. Take a look at your ticket submissions, see what people are saying, and create different focus areas and teams that are tied to those pieces. You can use it also as an opportunity to dive into your product engagement data and identify what people are missing. So for example, if you have an onboarding process and you realize that people are finding either different ways of using your product or they're getting stuck somewhere, this is a great chance to use that to be able to address some of those needs that your customers are pointing out by the ways in which they're interacting with your product. It also would be a really cool opportunity to ask customers to be part of the hackathon, to be part of your team, and to really feel like they're connecting even more strongly with your product or with your organization. So really looking at those key users and seeing if they would want to have an input in what it is that the product is doing. That's always a great way to do more outreach and to expand how people are interacting with your product, your service, or your brand. And then, of course, you can use it as a way to understand and share out some of that user experience. So as part of the process, teams could have to talk to different users or watch the users use the thing that they just built to better, again, understand how users are engaging with your product. And so as we're going through and potentially thinking about how to host our hackathons and how to host them in a way that's going to help our organizations grow, our products be more innovative, and then also making sure that our teams are able to come together, connect, build together, there's a couple things to keep in mind. The first and foremost is that dynamics that make tech challenging for certain people, again, these are the outcomes that we see when we have a lack of diversity, equity, and inclusion initiatives and action plans within our organizations, are really only amplified or heightened within a hackathon setting. So if there are certain things that your organizations needs to work on, this is a great way of taking a moment and working on those first, because hackathons can really just amplify some of that. So that's something to keep in mind. And on top of that, the way to mitigate this is to really, again, work on kind of your organization's culture, but then also to see facilitation and programming as the key. Most of the work that makes hackathons successful, from my perspective, is not actually necessarily the hackathon itself. It's all of the work leading up to the hackathon. So it's thinking about how are teams going to interact with one another, how are you going to provide opportunities for people to address conflict or enhance communication, how are you going to make sure that everyone feels like they're getting their voice heard. And so that facilitation and programming that happens prior is really 90% of the work. And also, how do you keep it entertaining and dynamic? How do you make it something that's fun and exciting and people will want to keep doing? Something else to keep in mind, of course, it's connected to my prior point, is that you should really be centering certain core values within that hackathon process. Part of it, I would say from my perspective, is including things like inclusion and accessibility as key components and key lenses through which you're seeing, through which the teams can be working, the lens through which the teams will be working in. And so a lot of that is just, I think, from just hearing people's stories around being in hackathons. And I think one of the things that made Hack the Gap really exciting for me the first time I experienced it is that it just felt like a place that I could belong inherently, and that I could learn and ask questions in a way that didn't make me feel like I didn't know what I was doing, but it was really a chance to learn and grow and find mentors and friends. And so part of that is around providing the necessary tools that are necessary to have teams that are communicating with one another, and having some of those collaboration tools. So also providing very tactical things, like if you have a virtual team, access to things like Zoom, stuff like that, giving them hints or opportunities for them to test out different ways of deploying the code or testing something out, as well as just literally within their team settings as humans to humans, how do they work together and work with one another in order to compromise and address the things that come up when everyone has a great idea, right? And a lot of that just has to do with facilitating an environment that really centers equity and voice, and it centers the fact that everyone should be part of that process inherently, regardless of the role that they're playing. So not one particular role is deemed as more than or more necessary than any other one, but everyone is really part of that team and part of that process. And so again, how does everyone get to share their input, not just in the team setting and beyond? So even as folks are sharing out what it is that they worked on, how does that share out process encourage everyone to speak to the project if they want to speak to it? How do you make sure that credit is shared across the team? And it's clear that it really was a team and a collaborative process. Those are the key little things that make an experience one that people will want to have over and over again. And then, of course, gathering feedback and continuing to work on some of the things that worked, leveraging the things that did work within other parts of your organization or your day-to-day work, but just keeping that process something that's ongoing. All right, so that's all I have to share. Thank you so much. Feel free to follow us at hackthegap.com or Hack the Gap on Twitter and Instagram. Let me know if you have any questions. My email's down there. Thanks again.
Thank you so much, Caroline. You can just give that to them back there. Or actually, I'll take that. Thank you so much. I appreciate it. That was fantastic. So I like hearing that because I admit I'm one of those people when somebody says, let's have a hackathon, and I'm like, oh, I don't know what I would do. It just seems hard to plug myself in. And just seeing there's a lot of different ways to use it in your organization to make a lot of positive change happen. Wonderful. Okay, well, we're going to take a quick moment to hear about what happens after lunch, the thing after lunch. Would you like to give us some info? Introduce yourself and give us some info.
Sure. So who here knows what these are for? Good, that's a lot of you. Nice. So after lunch, we are going to do the only open spaces of this conference. Open spaces are a great time. If you've thought of some ideas, some questions, some lingering things that you want to learn more about or talk about in general, open space is the place that you do that. So it's the unconference part of our conference where the participants, as we call you, actively participate. By the way, I'm one of the organizers. I'm Andy Fleener. Yeah, I will be setting that up along with one of my co-organizers here at 1:30, I think is when we get started with proposals. And then I think we have an hour to sort the schedule out, and then they will start promptly after that. So yeah, come back after lunch. It's going to be fun.
Thank you so much, Andy. Okay, so you're thinking, wow, there's an awful lot, and I thought I just had to, I don't know, click button, get cloud, something like that. Well, maybe, but there is a lot more to it, and we are fortunate to have our last talk of this conference be local leader, Jenna Peterson, who can tell you exactly how you can get from, I would like to do some cloud stuff, to how do I actually do it and do it well. So without further ado, please give it up for Jenna Peterson.
Thank you. Is there a clicker anywhere? That's okay. I don't see it.
I totally put it in my pocket.
It's not going to work from there.
You can put my mic back up, and I can admit I am very distracted because conference. Thank you so much.
Thank you. All right. Hello. I've missed you all. Thank you so much for being here today. My name is Jenna Pedersen, just like Bridget said, and I'm excited to talk to you about one of my favorite subjects, which is software development best practices, but with a twist of bringing those practices to our infrastructure. So I want to start with a fun fact about myself. Once upon a time, I had the phrase automated test fanatic on my business card. And that was a while ago, and I'm very passionate about automated testing and testing in general. I feel like there's always a place for testing in whatever you're doing, whether it be learning a new framework, working on a side project, or even deploying a large-scale application into the cloud. And the challenge, though, is that there is, you have to find this happy balance of how much and what kind of testing to do for it to be effective. And so we're going to talk a little bit about that. So first, with a raise of hands or a note in the chat if you're virtual today, how many of you are using infrastructure as code, or you work on applications that run on infrastructure that's managed with code? Excellent. Okay, great. And if you're not, that's okay too. There's something for you here as well. So just a refresher, infrastructure as code, it helps you automate deployments of your infrastructure. It lets you quickly provision those resources. It lets you do it consistently, so across different instances or across regions. And it lets you do that at scale. But what happens when something goes wrong? Well, maybe you've already earned this badge, the Works on My Machine badge. I certainly have. And maybe it works on your machine or your account or your region. But what can happen is when we are deploying many resources, hundreds of resources to the cloud using infrastructure as code, things can break at scale. And that blast radius is much wider. So more resources, more regions, more customers, and more dollars are impacted when this happens. So your infrastructure as code is code. And do you treat it as code? Are you version controlling it? Are you testing it? Are you code reviewing it? Are you pushing it through different stages of your CI/CD pipeline? And how do you know when that infrastructure is out of sync from your code or has drifted? And how do you verify and validate that what you built is what you meant to build? And how do you verify that what you built is actually built correctly? So that's what we're going to talk about today, is treating your infrastructure as code and minimizing that blast radius. So we'll touch on the different types of testing, test-driven development, testing your infrastructure directly, and using a CI/CD pipeline. So the cloud, it makes it easier to quickly provision infrastructure, but there's complexity with that scale. So if you're going to multiple regions or you have many different instances, that blast radius is a lot wider. It's more complex. And so infrastructure as code helps you manage that complexity, but automated testing can also help you manage that complexity. And so by building quality in from the start, with some of our testing processes and processes like CI/CD, we can do that just like we would do our application code. We can do that with our infrastructure code and our infrastructure. So that's going to give us more confidence at scale and at velocity as we change or add to our infrastructure. So as you're building out your infrastructure testing strategy, you're going to take a similar approach to determining what kinds of testing you want to do that you would do with your application code. It's just going to be a little different testing, that's all. So you've probably seen this testing pyramid before, or a variation of it. The tests at the bottom are going to be fast and cheap. They're easy to create. They're quick to run. They give you feedback a lot faster. You can run them more frequently. The tests at the top are going to be slow and expensive. They're harder to maintain. They're often more brittle. And in the case of infrastructure testing, they can be more complex because it involves actually provisioning and deprovisioning cloud resources and actually running tests that hit those resources in the cloud. So we still need that balance of the fast and cheap tests with the slow and expensive tests. So if you're test driving your application code, why not do the same with your infrastructure code? So what's actually stopping you? And if you're not familiar with test-driven development, here are some of the benefits. It helps us reduce our defect rates. It can improve the overall design of your system. It is very focused on requirements, and what I mean there is it helps you build only what you need and what you intended to build, so you're not building extra things that can break later on. It's also focused on small chunks, and this is to help you isolate issues and fix issues a lot quicker when you do have them. And it also serves as documentation for your team and for the requirements of your system. And lastly, it also gives you confidence. And this is confidence in what you're building or what you're changing, so that when you do have to make a change, whether it's a planned change or it's a unplanned change, because those do happen, it gives you confidence in those changes. So with our infrastructure testing, we can also follow the test-driven development flow that we would with our application code. So the rules there, or the guidelines, or the steps for this flow are that we first write a failing test. So it might not it might not compile, or it might just fail like a normal test fails. The second step is that we actually write only enough production code to make that one test pass. And then we improve on that. And we keep following that process, those 3 steps, the red, green, refactor steps, until we've built up more tests and more production code, and we've built out whatever it is, our feature or our stack or whatever it is that we're building. So let's talk about those cheap and fast tests for a minute. So unit tests, they're going to exercise a small part of your application or one unit and verify that it's correct. Traditionally, unit tests are going to be isolated from other resources and from external APIs. So for instance, if you're building a CRUD app, you don't need to test the database and the access between the database, because we already know that works. That's already a relatively well-tested piece of functionality. So we don't need to be focused on that. We just need to be focused on what our part of that application needs to do. And because of this, this reduces the scope and number of variables that can affect the results, and helps us identify what actually goes wrong when something does go wrong in our code. So we can take this same process and apply it to our infrastructure code. And I say code here, not infrastructure. We actually don't need to provision any resources or even a little part of that to test what we're building and to test that we're configuring it correctly. And so when we have infrastructure-based unit tests, it's now checking that a resource is created with the correct configuration. It's the correct number of that the correct number of resources is created, that dependencies between those resources are created, and that interpolated values are correct as well. So if you can imagine provisioning a database, and I did this several times as I was building up the demos for this talk, it's not a small amount of time to provision or deprovision a database if you do something wrong. It's like, for what I was doing, one instance, it was like 10 or 15 minutes to spin it up, and then another several minutes to take it down again. And as I code, I make a lot of mistakes, which is why I do unit tests. And so unit tests are going to help you with that process. So they're cheap to write, they're cheap to run. We can run them more frequently, which means we can get feedback into the feedback loop a lot quicker and know when something goes wrong. So I can write a test to see, did I configure this correctly? And if I didn't, I know before I've tried to provision that database that it's not going to be right. And we'll see that in just a minute. Again, unit tests are going to serve as they can serve as your documentation, communicating requirements to your team. Oftentimes, I've worked in a lot of large legacy databases, and when I go into a new database, I take a look. What are the tests that are there, and are there any unit tests? Are there any integration tests? And I can see right away if how a certain component works or how a certain stack is supposed to be set up if there's actually tests to look at. And additionally, because we're automating these unit tests, we can run them in our CI/CD tool, again, to get feedback into our loop a little bit faster. So in this first demo, I really want to show you that it's possible to test drive your infrastructure code. For context, this is an AWS CDK app, so an infrastructure as code framework. And we want to create a private S3 bucket that has encryption enabled by default. So we're going to write a failing test with the Jest framework, a unit testing framework. And then we'll write the infrastructure code, which is our CDK code. And then we'll make sure that our test passes. So the first thing that we're going to do is, I've got some of this already bootstrapped. The project's here. The test is created. We're going to set up this test to have a S3 bucket stack. So we're going to create that stack in our test. And then we're going to set some expectations on that stack. So we're going to expect that this stack has a resource, an S3 bucket resource. And I want to make sure that that S3 bucket has certain properties set. And this testing framework, what it is doing is it is inspecting the CloudFormation templates that get generated by the CDK. We are looking at bucket name, we're looking at bucket encryption to make sure that those have been set. So once we have our test written, we'll go in and run the test. You'll notice that there is a compilation error there, and after we build and run this test, that's what it's going to tell us. We have a compilation error, and that's totally okay to have that on your first test, because a lot of times you have no production code there to actually test against. So that's what we're going to do, is create that S3 bucket stack. So this particular file is a CDK stack. We're just setting it up, the constructor, the way that this framework requires. And then we are going to create a S3 bucket here using the framework as well. And give it a name or an ID. This is not the bucket name or the bucket ID. It is just the logical ID of the resource in this framework. Then we give it a bucket name. We're going to block public access. And you'll probably note that I forgot to add a test for that. So later on, maybe today or tomorrow, I'll go in and add that. So then we build and run our test again, and it fails because I also forgot to implement something. So we wrote our test expecting that our S3 bucket has encryption enabled by default, and I forgot to add that to our production code. So, and I can see that here. There is a lot of output here, but we can see that there's a S3 bucket resource that expected bucket encryption, but it's missing. So go in and add that. And we'll rerun the test. And there should be a success here. So we have our code. We've got our code, and our tests are written, and now we can actually provision our infrastructure in the cloud. And once we've done that, though, how do we know that our infrastructure is actually correct in the cloud? I could go into the AWS console and tap, and manually check all my resources. I might have to do that across regions. I might have to do a whole bunch of EC2 instances and make sure that their dependencies are correct and make sure I have access to it all, make sure that different things are connected to each other, but that sounds like a lot of work. I don't like doing work. So what we can actually do is write some automated tests around that. So we can test our deployed resources, and that's where integration testing is going to come in. So an integration test is where we are testing the interactions across different units or modules, or in the case of infrastructure testing, we're testing the interactions across different cloud resources. We're verifying that our provisioned resources are created and configured as we expect them to be. And this is gonna, again, this is gonna give you confidence in your infrastructure at scale and at velocity. So in the example that I'm gonna show in just a minute here, we're gonna use Chef Inspect, and this is an open source framework that lets you test and audit your infrastructure. And you can execute and write tests with a domain-specific language, so it's really easy to learn. And these execute on remote systems, so like servers, containers, cloud resources. And they can be used on any machine or resource regardless of whether it's provisioned with an infrastructure as cloud or infrastructure as code framework, or if it's created manually. So if, for instance, maybe I have a stack of resources that I created with my framework, but then someone else goes in and creates resources on their own for something else, but they haven't actually put it into code yet. That can also be tested with inspec. So the other benefit to this is that because these are easy to read and to learn, other teams can write tests. So for instance, your security test or your security team could write their own tests because they have certain standards that they want every EC2 instance to meet. And that would be written in an inspec profile and then pulled into your test suite. So in this demo, I want to show you that it's possible to test your infrastructure code or your infrastructure directly, and that you can even test drive those tests right alongside your unit tests. For context, this is a different app. It's a CDK app again. There's already an EC2 instance and some related resources that have been created. They're provisioned already. They've been tested. And now we want to add a database to our app. So we're going to write a failing test in inspec. We're going to update the infrastructure code. And then we're going to make sure that both our unit test and our inspec test are passing. One thing to note, just before we get into the demo piece, a little bit more about inspec and how that's set up. I've already created what's called an inspec profile, and this is just a way for us to group related tests. Again, like I said, the security team might have their profile that groups their security-based tests. This framework, it's built on top of RSpec, which if you are a Ruby developer or if you're familiar with RSpec, it's going to look very familiar to you. Controls are, you can think of controls as your test file, so those are going to be declaring a requirement or a set of requirements about a group of resources. The describe block that we'll see here in a minute is grouping expectations for a specific resource. And then you can also, one interesting piece here is you can also set an impact, which is a number from 0 to 1, and the higher the impact, the more impact it has on your system if it fails. And so you can configure your test runner to pass or fail based on that impact score. So again, all of this is set up. We're just going to take a look at the unit test here. We're making sure that we have an EC2 instance that is configured correctly. We're making sure that there's an elastic IP for it. We've also added a unit test for our new database that we're adding, and we're expecting certain configuration values there as well. I've added some outputs to the CDK stack so that we can use them later on in our tests. We're going to build and run the test, and this should fail. And it's going to fail because we haven't actually created our database yet in our code. So if we go and look at our production code, again, we've got some of the supporting resources for our EC2 instance, security group. We've got the EC2 instance itself. We're going to make sure that that's set up as well. And then I mentioned those outputs. We'll use those in our tests, and we're going to add a couple new ones there for our database. But before we write any production code, we're actually going to write our inspec test as well. So we've got our unit test that's failing. We'll also have a failing inspec test. Just for a very simplified version of a test, because the other one's a little bit more complex, we have a control. You can see the impact here is set to 1. The describe block is testing against a specific resource. And then we have certain specific expectations on that resource with that ID. And so when we go to this, the full stack app control, before we do that, we'll look at files. There's nothing in there yet, but that's where our outputs will go from our stack. And this is just a look at the inspect profile. That depends block is where we put other profiles that we want to depend on. So if we had our security profile that we needed to make sure we ran those tests, this one here is giving us AWS support as well. So here we are, this is our inspect test that we're going to be updating. Right now, all it is doing is testing our EC2 instance and security group. And we've got these parameters here that I'm taking from an outputs JSON file. And we are doing that so we don't have to hard code those values in our test. So we've created the resources in the cloud, and we need those IDs of those resources to actually test against. And so we will use those in our tests. So quickly run this test just to make sure it's still failing. Or this one's going to be successful because these resources are already provisioned. They're already in the cloud. And then we'll go in and update this test to add, we're going to add a couple more parameters that we want to, outputs that we want to use as IDs that we're going to test against so we can find those resources. We're going to make sure that our database security group has access on port 5432, which is for Postgres. And then we're going to make sure that our RDS database instance is provisioned with the Postgres engine, a specific version, and a specific instance class. So again, here we're pulling in that database identifier from the outputs file that will, when we deploy our resources, we're going to get that data back. So once we've written this test, we're going to go back to the command line. We will run it again. And we're going to have that failure. And this failure is specifically because we don't have I think it was our outputs, the database security group ID and the database instance ID in our outputs file because we haven't provisioned that infrastructure yet. So we'll go into our CDK code and we're going to add the database now. So we've added our database instance, we've given it an ID, configured it the way that we want it. We've given it an instance identifier. We've said we want it to be Postgres, this specific version, this instance type, giving it a couple of tags so we can find it later. And then we're also going to add this connection so that our EC2 instance can talk to our Postgres database. So that line there, we did not test in our inspect test or our unit test. So I think actually it's in our unit test, but it's not in our inspect test. And so that would be something we could add later. Then again, we need these outputs for our inspect test. So we're going to add database instance identifier so we can find that resource and run our test against it. And then the database security group so we can run our test against that as well. So once this is ready, so those outputs, they're going to show up here in just a minute once we've actually provisioned this, deployed it. So we've updated our test. Now we're going to go back to the command line, run our unit test again. So this unit test, we've actually written the production code for it, so it should pass, and it does. Now we're going to generate this CDK framework. Like I said, it's backed by the CloudFormation template, so we generate the CloudFormation template, and then we're going to deploy it to the cloud. And this is that process that I mentioned earlier that takes I think when I was recording this, it was 25 minutes or something obnoxious like that. And we don't want to wait around for that, so I sped this up a little bit. We're passing in any parameters that our stack needs, and then saying where should our outputs go. So our outputs from this deployment of these resources are going to go to that outputs.json file. So again, This is going to take a little bit. And we've got a successful stack, and the output's created. So now we can actually run our inspect test against our infrastructure. So this is testing, it's going out to the cloud, and it's testing our EC2 instance to make sure it's there, it's running. It's doing the same thing with our database that we just added to our code. So we've built all this stuff up, but one thing that can happen is our code can become out of sync with our resources that are in the cloud, and that is known as drift. And inspect can actually come in handy here and test. These tests can make sure that our resources have not drifted from what we are expecting to be there. So other frameworks, they can only detect issues or detect drift for the resources that they know about, the resources that they manage or that's in your code. And so this is just one way of being able to detect that drift. And being able to do this gives you the freedom to choose whether you want to fix your code or if you actually just want to temporarily fix it in the infrastructure itself. So you might be wondering, Jenna, why did we build all these infrastructure tests? What are we going to do with them now? Well, that's a great question. So your CI/CD process might look like this today if you don't have any infrastructure tests, or maybe you don't have any tests at all, and it definitely looks like this, but that fire is really, really big. So you're probably not finding issues until they get to production. And if you're not finding the issues, your customers are. And so this is where infrastructure as code can come in handy, and it can help you with your CI/CD process because it relies on infrastructure automation in order to create consistent environments and to have a consistent test process and to be confident in each step of your environment or each phase of your pipeline. But when you do have tests in each phase, your fires are a lot smaller in between each of those stages, and then you are slightly more happy at the very end because hopefully you're having less problems in production. Your customers are finding less issues in production. So we can actually put all of this infrastructure code through the same CI/CD pipeline that we might do our application code. And this is going to help us find bugs earlier in the process when they're cheaper and easier to fix. So I just want to leave you with a few parting thoughts. I encourage you to code review, version control, test, unit test, integration test, run your infrastructure code through a CI/CD pipeline. Even if you're not testing your code in production, your customers certainly are. And the earlier you catch bugs, the cheaper it is going to be to fix. So thank you. If you have a moment, I would appreciate feedback. I hope this isn't the last time I get to give this talk. So I would like to make it better. Any feedback you can offer, whether it's through the survey link or on Twitter, whatever, I would greatly appreciate that. The bottom link here is a GitHub link to view the demo code that I showed. I know we went through it really fast, but it's all there. And yeah, thank you.
Okay, thank you, Jenna. That was fantastic. I would like you to all know I just narrowly avoided tripping on that again because I was trying to step from a weird angle. And I tested it yesterday. So, okay, so what we should know now, what everyone should know now is we have lunch, and the live stream for the live stream participants is going to end when I leave the stage here. But we're not going anywhere. We're just going to be doing open space proposal stuff in Zoom and on Slack. And then for the in-person proposals, there will be on-stage, discussion and proposal. It's just that if you're looking for the live stream and saying, what happened? We are stopping the live stream after this point, but we are having the in-person and the online collection of ideas starting at 1:30 p.m. Central Time. Until then, please go visit the sponsors, get yourself snacks, and one inducement if you're thinking, do I want to stick around if I'm in person and have in-person discussions later today? There is going to be ice cream bars at 2 p.m. So just so you know, there's a sponsor raffle at 2:30 p.m. and they're giving away things. There will also be sponsor raffle stuff online. So if you're looking online, thinking, if you're watching online and you're thinking, so you're turning off the live stream and then I have to go interact with people. Don't worry, all the links are in where you signed up to be an online participant for the Zooms. And make sure you register for all those sponsor raffles because online or in person, there are many, many great choices. All right, thank you so much. And we will be here after lunch, 1:30 p.m. Thanks.